do a quick example from the first problem on your work. So today you're going to use your knowledge of angle relationships, algebra, and proofs to solve the problems below. Your 3.5 notes will be very, very helpful if you need help coming up with your justifications here. Now, you'll notice that your 2-column proofs only have one row. If you right-click or press with 2 fingers on your trackpad at the same time, you can add more rows to your table. So you only have to add the number that you need to get there. Okay, so here we are given the diagram below and we're asked to find the value of x. So here we can start by saying that we have our diagram, because that is given. And based on our diagram, we know these two angles have to be congruent because they are vertical angles. That means that they're also equal. So 6x plus 7 equals 8x minus 17. Vertical angles are congruent. Now here's another way we can do this. We can actually hit insert equation right here, and then when we type our math, it looks a lot better and it lets us use more symbols. Okay, so now I need to insert another row. And I know I want to isolate my variable, so I'm going to need to subtract 6x from both sides so I can get all my x's on one side. So the next step here would be insert an equation. 7 equals 2x, because 8x minus 6x is 2x, minus 17. And we used our additive inverse. Now remember, we have to say what we did, so we subtracted 6x. Next, we're going to use our additive inverse again because we want to get rid of this minus 17. To cancel out a minus 17, we'll add 17 to each side. 7 plus 17 is going to give us 24. And then this one will end up canceling out, so all that's left on the right side is going to be 2x. That was our additive inverse again, but this time we did plus 17. Okay, now to get our x completely isolated by itself, we need to divide by 2 on both sides. And that would leave us with 12 equals x. It's our multiplicative inverse. Divide by 2. But we're not necessarily done, because remember when we talked about our special properties in our 3.4 notes, so actually your 3.4 notes will also be helpful. And we said generally we don't like our equations to look like that. We like the x or the variable to be first. So we can actually do that one last step and say x equals 12. And we know that that is true because of our symmetric property. And this is on your 3.4 notes if you need to review that. And that's the end of our proof for that one. So we had to use the diagram and our angle relationships in order to figure out what our first equation was. Some of the angles are going to be supplementary, so we would need to add them and make them equal 180. Then we used our algebraic field axioms. And finally, we used one of our properties from our 3.4 notes. Okay, the second one, it says we are given that angle 2 and angle 4 are vertical angles, and we want to prove that angle 2 equals angle 4. So we just used that property up here, but now we're going to prove it. So our first step is always to start with our given, and that's that angle 2 and angle 4 are vertical angles. You'll definitely want to insert an equation here. And then to get the angle symbol, you're going to come over here and we're going to look and find our angle symbol. Okay, to do that, we're going to insert a special character, and we're going to search for an angle, and there's our angle symbol right there. Oops, I accidentally added 2. Okay, angle 2, and I'm just going to copy and paste Control C, Control V, angle 4 are vertical angles. That is our given. Now, in order to prove that they're congruent, we're actually going to need to either choose angle 1 or angle 3 to help us do that. And that's because here we have a linear pair with angle 1 and 2, and here we have another pair, a linear pair with 1 and 4. So then if we use our algebraic properties, we'll end up finding that angle 2 and angle 4 are the same. Okay, that's the way we're going to go. So what we would say next is, I'm going to copy my angle symbol. I'm going to say angle 2 plus angle 1 equals 180 degrees. And that's because they're a linear pair. Can insert a row below, and we're going to say the same thing, but this time we want angle 4 and angle 1. Same reason, they're a linear pair. Then, because they are both equal to 180, because 2 plus 1 equals 180, and 4 plus 1 equals 180, that means these two left sides have to be equal to each other. That's our transitive property from our 3.4 notes. So that means this has to equal this. And that's on your 3.4 notes. Now we want to find that 2 and 4 are congruent. So what we need to do is get rid of these angle 1s. That's actually pretty easy because all we have to do is use our additive inverse minus angle 1. And then right now we have that those angles, oh, I should have m's this whole way through because we were talking about numbers. We were talking about the actual measures of those angles. Okay. Now the goal was to show that they were congruent, not that they were just equal. But that's okay because we have our congruence theorem for angles, which says that if 2 angles are congruent, then they're equal, or if 2 angles are equal, then they're congruent. So here I'm actually going to search and find our congruence symbol. It's the one that's an equal sign with the squiggly line. Mine is very small. Let me make it larger so you can tell. There's our congruence symbol. And that is because of our congruence theorem, specifically for angles, because there's also one for segments. Okay, those are the first 2 examples. You have 4 more problems that are just like those. Let me know if you need any help. Have a great day.